Hello.
Good evening, sir.
Yeah, good evening.
Good evening.
Yeah, good evening. Can you hear me, everyone?
Yes, sir.
Loud and clear, sir.
Okay, so we'll start today with a little bit of theory, some theorems that you need to solve the remaining problems. We have to do till problem 275, and you will need some of the theory there. So I will just introduce the results that you will need. So most of them are familiar to you, should be familiar to you. If you don't know, then we will discuss it right now. So first one is basically chord central angles theorem. Central angles theorem, which basically says that if two chords are equal, then the angles that they make at the center are also equal. Then the angles that they make at the center of the circle are also equal. So, by the way, this follows from the basic meaning of how you describe an angle at the center. So, if this is an arc, the measure of the arc is this angle in radian, right? So, if you join it with lines like this, if there is a chord like this, it's an isosceles triangle. So, the length of the chord totally depends on the cos theta here, right? You can easily say that the length of the chord, if it is L, you can apply cosine rule here and say cos theta is equal to r square plus r
R
square
square
minus L square. So 2r
by
square
2R
minus
square.
L square by 2r square.
Yes, sir.
So basically that means that 1 minus L square by 2r square is equal to cos theta. So your length of the chord L square is equal to 2r square into 1 minus cos theta, right? Since right now we are talking of a single circle, if there is another chord somewhere here making an angle theta 1 at the center and length is L1, we will have a similar relationship for that. It will be like this: L1 square is equal to 2r square 1 minus cos theta 1. Correct?
Hmm.
So it is obvious from there that if the length is same, then cos theta should also be same, and vice versa.
Yes.
That is the basic idea of your chord, equal chords subtend equal angles at the center. Then the second one is chord arcs theorem. Chord arcs theorem. And what does this say? So basically it says if two chords in a circle are congruent, then their intercepted arcs are also congruent. Then their intercepted arcs are also congruent. Obviously, almost the same logic. When you make a chord, you are already intercepting an arc on the circle, right?
So what is intercepted?
This is the arc that is intercepted by this chord.
Yes, sir.
If two chords have same length, then the arcs will also be congruent. That's the theorem.
हाँ.
It's an
Okay, sir.
obvious theorem.
नहीं वो सर intercepted का मतलब नहीं पता ना.
It is an obvious statement. There is nothing to describe here, basically. Third one is inscribed angle theorem. Inscribed angle theorem. And basically, that means that the measure of an angle inscribed in a circle is 1/2. Basically, angle at the center is twice the angle on the circumference. If both the angles are coming from the same chord. The proof of this is also not difficult. It's just about some triangles and all. You have to prove that this angle is twice of this angle. Do you understand what I'm saying?
Yes, sir.
So you can easily prove it.
Yes, sir.
Isosceles.
This is the
Isosceles
isosceles
and
triangle,
exterior angle property.
right? So if it is isosceles triangle, basically you know that this angle and this angle are same. So if that is theta, theta, this angle is 180 minus 2 theta, right?
Yes,
You
sir.
should probably join this and you'll get another isosceles, right?
Yes,
There will be a sequence of multiple isosceles triangles here.
yes, sir.
You should try angle chasing. You should be able to prove it yourself. Like, I don't want to do it because I think everyone should do it themselves. This is easy only. So that theorem everyone is aware of, right? Angle at the center and twice the angle at the circumference.
Yes, sir.
Yes, sir.
Obvious consequence of that is that angle in a semicircle is 190 degree. Is 90 degree because if you have a semicircle, then what you're talking about is the arc. This arc is a semicircle. This is the center. So the chord basically is AOB chord, and the chord makes an angle somewhere here, X. So this angle should be double of that, right? But this angle is a straight line because this is a diameter, so this is 180, so this should be 90. Using the previous theorem, we can prove that angle in a semicircle is 90 degree. And obviously, any place you make this angle on the circle, everywhere it will be 90. I hope that is clear.
Yes.
Yes.
Then we have intersecting chords theorem. Intersecting chords. Basically, we have a circle and we have two chords that are intersecting. Let's say A, B, C, D. And we are saying the measure of the angle formed by two chords that intersect within a circle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So basically, this arc and this arc. If you call this arc alpha and you call this arc beta, when I say alpha and beta, I refer to the measure of the arc. What do you mean by measure of the arc? The
The length.
angle that it makes at the center. Angle that the arc makes at the center.
Yes.
So you can prove that this angle theta will be equal to 1/2 of alpha plus beta. And in case the intersection was outside, suppose the situation was different and the intersection of the chords was outside, then that theta would be 1/2 of the difference of these two arcs. Do you understand what I'm saying right now? Try to prove this. So make a center here. You have to prove that this angle is alpha, we know, and this angle is beta. You have to prove that alpha plus beta by 2 is equal to this angle. Maybe make a slightly more different figure. Mark the center clearly and let the chords intersect somewhere here. A, B, C, D. This is one arc and this is one arc. Measure of these arcs are alpha and beta. We have to find this angle. Try to do it. Prove that theta is equal to half of alpha plus beta. Is anybody getting it? If you join B and D, we know that this angle should be beta by 2, right?
Yes.
And if AD basically will make at B, what is the angle here? Alpha by 2.
Yes, sir.
So theta is clearly exterior angle.
Yeah.
Is everyone understanding what I'm saying? It's one step only actually. The arc AD's measure is alpha. So the angle that it makes at the center is alpha. But what does arc AD make at B? It will make alpha by 2, right?
Yeah. Yes, sir.
Similarly, arc BC makes angle beta at the center. But what does it make at D? It will make beta by 2. So now look at the triangle PBD. In that triangle, alpha by 2 plus beta by 2 will be equal to theta because theta is exterior angle. I hope everyone is understanding what I'm saying.
Yes, sir.
What about the others?
Yes.
Similarly, you can also show that if the chords are intersecting at point outside, then the angle theta will be the difference between the arc measures. So if these arc measures are alpha and beta, theta comes out to be half of alpha minus beta. you can also try to prove this. So basically, if this is alpha, I know that this angle is alpha. This much is alpha, right? And I know that this
हाँ.
angle is beta, right?
Hmm. Hmm.
I need to
Yes, sir.
find this angle. So, okay, fine. So, what do I have here? These are radiuses and all.
Hmm.
So, if I make a triangle like this is isosceles triangle. I know this angle, right? I know this angle and this angle,
हाँ.
correct?
Yes, sir.
Similarly, a little bit of angle chasing. This angle is what? This angle is actually 90 minus beta by 2, right?
Hmm.
I also need to find this angle somehow because that is also equal to these two, right?
Hmm.
So, okay, so if this is alpha, but they are not collinear, so I have to draw a bigger figure. Measure of this arc was alpha, measure of this arc is beta. Okay, let me just make some angles like this. Like, let's say, what is the angle made by the arc at this point? This point would be beta by 2, right?
Yes.
Hmm. Yes, sir.
And what is the angle made by this arc okay, at this point, see, this point is alpha by 2, and now it's over again. We don't have to connect to the center ever. Do you see that it is over now?
अच्छा हाँ. Yes, sir.
If you connect at the center, it becomes complicated. Do you see that it is over?
Yes,
Yes.
sir.
In one step only it is coming. You just think of the arc's angle at the circle, not at the center, right?
Hmm. Yes, sir.
And automatically triangle is complete and you're getting this. Correct?
Yes, sir.
Okay. Next theorem is alternate segment theorem. This is very important. Does anybody know what this is?
Yes.
What is it?
So in a circle and a triangle made. Yes, sir.
Triangle? नहीं, triangle की जरूरत नहीं है. Alternate segment theorem should not be said like that. It is basically the angle between the tangent and a chord.
Yes, sir.
Does anybody know it properly? Can you tell me? So what I will do is I'll make a tangent at a point P. Let's say this is a tangent. And let's say there was a chord that passes through it. So PQ is a chord, PT is a tangent, right? If I want to find the angle between PQ and PT, this angle, theta, then what you have to say is that the angle between a chord and the tangent will be equal to the angle that the chord makes in the alternate segment. So first of all, realize that any chord divides a circle into two segments, right?
Hmm. Yes, sir.
So PQ has divided the circle into segment 1 here and segment 2 here, correct? Now,
Ah, yes, sir.
what you need to find is the angle between the tangent and a chord. Tangent is PT, chord is PQ. The angle is theta, which is angle QPT. And the property, the theorem is saying that this angle will be equal to angle PQ chord makes in the alternate segment. Alternate segment is the segment not containing theta. Which is the alternate segment here?
S2.
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 So S2 is the alternate segment, and basically what angle will the chord make in S2? So you take Q and join it to any point in that segment on the circumference, this angle, or it could be this angle. All the angles will be same, right?
Yes, sir.
So all of these angles are going to be theta basically. That's the theorem. That the angle between tangent and a chord is equal to the angle that the chord makes in the alternate segment. And now you have to prove it. In this one, it is better to draw the circle center. We know that OP will be perpendicular to PT, right?
Yes, sir.
Because PT is tangent. So if this angle is theta, I know this much is 90 minus theta, right? So obviously, if I join OQ, this is also 90 minus theta. So therefore, this angle is what? 2 theta.
2 theta.
Therefore, any other angle by the chord PQ will be
Theta.
theta. So basically, we have proved that this theta is matching this theta or any other point on the alternate segment, right? Is it clear?
Yes, sir.
That is alternate segment theorem. It is very important to know it and to be able to use it. Then the next thing is tangents from an external point to a circle are equal in length. Tangents from an external point to a circle are equal in length. Basically, it is saying that from an external point, if you draw two tangents, let's say at T and Q, P, we can say that PQ is equal to PT in length. Obviously, because of Pythagoras theorem.
And yes, sir. Yes.
So you can join it to the center. This is 90, this is 90, and join OP. These triangles are congruent. So PQ will be equal to PT. This angle will also match this angle. This angle will also match this angle, right? Everything about these triangles will be same. So if I have a situation like this, PQO, and like this, I have not drawn it properly, but you have to imagine they are same. Then the height of both of them will be same. Everything is same, they're congruent, right? Are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Okay. Then power of a point we have already discussed briefly, right?
No, sir.
Okay, so power of a point theorem is a super important theorem. We will go into much more details of it in a future class when we go to part 2. But for now, we will talk about it like this. If there is a point P and there are circles, 1 second, hold on. I want to say the statement properly. Let's say P is a point in the plane of a circle. And from P, you have drawn two lines that cut the circle at points A and B and C and D. And this is P. Do you understand what I have done right now?
2 seconds. Yes, sir.
Yes, sir.
Two secants are drawn from P. Then you can prove that always PA times PB will be equal to PC times PD. The proof of this is simple only. It is a similar triangles proof.
Yes, sir.
You should join A and C. You should join B and D, right?
Yes, sir.
Now, if you see here, this triangle and this triangle. So think about it. Think about triangle PAC and triangle PBD. First thing that you should notice is the angle P is common to both,
Hmm.
right? Then after that, what you can think about is this angle. Let's try to figure out which angle in the small triangle is equal to this, right? So if you think about it, this is a cyclic quadrilateral. So if this angle is theta, this angle is 180 minus theta, right?
180 minus theta. Yes, sir.
So this angle is theta then. So basically, angle PCA is equal to angle PBD is equal to theta. Is everyone understanding what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes,
the
sir.
triangles are obviously similar, and as soon as you get similarity, you can write the ratios of the sides now. We can say opposite to this angle theta in the small triangle is PA, and opposite to theta in the big triangle is what? PD.
Yes, sir.
Should be equal to opposite to angle P in the small triangle is AC, and opposite to angle P in the big triangle is BD, right?
Yes, sir.
Okay, so right now what I have gotten is PA times BD, which is slightly weird. Okay, fine. Is equal to PD times AC. That's fine. What I will do is I will add 1 to both the sides. Like, don't do this multiplication right now. Add 1 to both the things, right? Okay, before you do that, you should switch the ratios. PA by
Sir, we can
PD.
use that PA by PD is equals to PC by PA by BB is equals to PC by PD from CPST.
What is CPST?
मतलब congruent part of similar triangle.
तो वही तो यूज कर रहे हैं, क्या
नहीं,
तुम बोल रहे
आपने
हो?
AC अपॉन BD ले लिया, आप PC अपॉन PD भी तो ले सकते हैं डायरेक्ट, सर.
PC upon PT. हाँ हाँ, why am I taking it like this? Right, obviously. I don't have to take it like this. I was just showing you the ratios. But in order to prove it normally, prove this, you can directly say that. No, that's the point. You are only wrong. I was right when I was writing it.
वो तो रेशियो ही
Corresponding.
नहीं बनेगा
नहीं,
हाँ
उससे नहीं बनेगा, सर.
क्योंकि वो तो सिमिलर नहीं है, वो उल्टा साइड सिमिलर है.
हाँ, सही बोल रहे हो रुद्रोजीत. अनिकेत, तुम ध्यान से देखो. मैंने ये रेशियो ऐसे क्यों लिखा है? Because this is the correct corresponding sides. Do you understand what I'm saying?
सर,
Hmm?
सर एक्चुअली ट्रायंगल PCA सिमिलर टू ट्रायंगल PBD होना चाहिए, ऊपर ही गलत लिखा है.
PCA similar to PBD. उससे कोई डिफरेंस थोड़े है, यहाँ पे एंगल्स है ना.
नहीं सर, डिफरेंस आ जाएगा ना, क्योंकि इसमें लिखा है कि एंगल A इज इक्वल्स टू एंगल B दिख रहा है ना सर, जो आपने ऊपर स्टेटमेंट लिखा है. अगर PCA इज पीबीडी के सिमिलर होगा तो फिर पीसी अपॉन पीबी इज इक्वल टू पीए अपॉन पीडी हो जाएगा।
So something weird is happening, but it is obvious what we have to do. We'll try again. This is the situation. P is here. A, B, C, D. I need to prove that I know that there is similarity here.
यस सर।
So triangle PAD and triangle PBC, what angles are same? First of all, the angle, one common angle, right?
हाँ, एंड सर एंगल एंगल पीडीए इज इक्वल टू एंगल पीबीसी।
हाँ,
तो
so
डी पहले आएगा फिर यहाँ पे, अगर आप पीबीसी को लेके चल रहे हैं एंगल पीडीए इस, हाँ, तो फिर ये सिमिलर भी हो गए ए कॉन्ग्रुएंसी से।
they are similar, and
हाँ,
now what we
नाउ
will
सर वी
say
कैन डू ना
is
पीडी अपॉन पीबी इज इक्वल टू पीए अपॉन पीसी डायरेक्टली।
I will not do it directly. What do you mean directly? What you have to do
नहीं,
is opposite sides of corresponding angle, corresponding sides, no, are in
हाँ
the same ratio.
हाँ, तो वही तो सर यहाँ से आ गया ना कि ट्रायंगल पीडीए इज सिमिलर टू ट्रायंगल पीबीसी।
I will get PA by PC
हाँ, इज इक्वल्स टू
is equal to
पीडी
P.
बाई पीबी।
Hmm.
तो सर वही बोल रहा था कि डायरेक्ट आ जाएगा, हमें एडी और बीसी का रेशियो नहीं लेना पड़ेगा।
Is equal to the other side is, if you took out this angle, the
हाँ,
opposite of this is PD
बाई
and the
पीबी
opposite of that
पीबी।
is PB.
हाँ, तो सर वही बोल रहा हूँ कि अब पी ए इंटू पी बी इज इक्वल टू पी सी इंटू पी, वो हो गया।
Basically, the point was that you don't need this ratio for that proof. The third ratio that I had taken is not useful in that proof, power of a point proof. Is everyone understanding what I'm saying?
Yes,
Yes.
sir.
You have to take the ratio of the other two sides. These two sides are important for that proof, not the ratio of these bases. Is that clear? There's nothing wrong in what we had written earlier. It was just that we are not taking the correct side ratios. Correct?
Yes, sir.
So what we are getting is the product of lengths from P to A and then P to B. This product is same as this product. And this rule can be extended even in situations where there is one secant and one tangent. So let's say this is a secant, whereas this is a tangent. So technically you should imagine that there must have been a secant like this, यहाँ पे C1 and C2, but you kept turning the secant like this, then C1 and C2 are coming closer to each other, right?
यस सर।
So if you keep turning the secant, it will slowly become closer and closer to the tangent, right?
Yes, sir.
So basically, you still have the same condition, PA into PB is equal to PC1 into PC2. But as you make it nearer and nearer a tangent, you will end up with this result, equal to PC into PC is equal to PC square. Is everyone understanding what I'm saying?
Yes, sir.
Yes.
So this is also the meaning of power of a point P. So what we are saying is, so far we have that Px into Py is equal to Pa into Pb is equal to Pc square. All of this follows as long as you have a fixed point P and a fixed circle. As long as you keep your circle fixed and the point fixed. After that, you can keep taking any type of secant or tangent or whatever, and this will still be true. Correct? So
Yes,
that's
sir.
why we define this as power of point P with respect to circle is equal to, you can write it in any way. You can write it as PA into PB if AB was secant from P. what we have been doing so far.
तो सर इससे लोकेशन पता चल गया हमें पॉइंट पी की.
Or you can write it as PC square if PC was tangent to the circle from P. And PC square, you should realize, is actually OP square minus radius square. Right? What is
Yes, sir.
PC square? By Pythagoras theorem, it is OP square minus radius square, right?
Yes, sir.
So another way to define power of a point P with respect to a circle is equal to OP square minus radius square, where O is the center of the circle and R is the radius.
Yes sir.
Technically, it's the same as PC square, which is the same as PA into PB. We are just writing it in this way because that removes the need for having other points like A, B, C, and all. In the definition, we don't need other points. We just need the circle and the point to be fixed. Then power of a point P will be this. Right?
Yes, sir.
Yes, sir.
Now, if the point is outside the circle, OP will be bigger than the radius and power of a point will be positive. And if the point is inside the circle, OP will be smaller than the radius and power of a point will be negative. And if the point is on the
So what is the
circle,
use?
huh?
So what is the use of positive and negative
Figure
here?
out whether a point is outside or inside. There is no use. It comes out as positive or negative depending on whether it is outside or inside the point is in the circle. Power of a point value can be positive, negative, 0. If it is positive, you know that point P is outside the circle. If it is negative, it is inside the circle. If it is 0, then it is on the circle. Do you understand what I'm saying?
Yes sir.
Yes,
Yes,
sir.
sir.
I'm just saying the consequence of our definition. It's not like there's no use of it. The use will come in problems when we see. But as a consequence of our definition, that is coming, right?
Yes sir.
Okay. Now, later we'll get into more details of power of a point, but for now, this much is enough. You should know that point could be inside the circle P, and maybe we have made two chords through it. Power of a point tells us now the advantage of power of a point will be clear. You don't need to prove similarity. You can just say that it's the same point. So PA into PB will be equal to PC into PD.
हाँ सर मतलब हमने वो उसको अंदर खींच दिया बस पॉइंट को ले आके.
The point can be anywhere. P can be outside. If it was outside, then you would have Px and y. So Px into Py would be power of a point, right? But if it is inside, it will be PC into PD.
Yes sir.
Power of a point products are always distances from P to the other points where it meets the circle. Correct?
Yes, sir.
Yes sir.
Okay, fine. So we'll see applications of this in problems, and later in part 2 of the course, we'll get into more details and slightly harder situations. For now, you just need to know this much about power of a point. The next thing I want to talk about is cyclic quadrilaterals. So first thing here is obviously a quadrilateral is cyclic if opposite angles are supplementary. Opposite angles of a quadrilateral are supplementary. It is cyclic. So by that we mean that if this is my quadrilateral, this angle is theta and this angle is 180 minus theta. then we can say that ABCD is cyclic quadrilateral, right?
Yes, sir.
First of all, why is that? So if you think about it, if the situation is like this, we know that this is theta and this is 180 minus theta, right? Then how do we prove that all of these points lie on a single circle? Think about it, how to prove that. So what I would say is you can connect B and D, right? And draw a circumcircle of BDC. Circumcircle of BDC. And you have to prove that A lies on it. Is everyone understanding what I'm saying?
Yes, sir.
A better way to do it would be to connect A and C. Connect A and C. Don't connect this because then we have to divide those two angles, right? Draw the circumcircle of ABC. Do you understand why I have switched the diagonal?
हाँ, क्योंकि सर उधर ट्राइंगल्स को डिवाइड करना पड़ता है ना, एंगल्स को, लाइक थीटा एंड 180 माइनस थीटा को.
We will try to prove that D lies on the circumcircle. It is guaranteed that as long as I have a triangle, A, B, and C are definitely going to lie on one circle, right?
Yes, sir.
So that is
Yes,
already guaranteed. Now we just need to show that if this angle is 180 minus theta, then it lies on the circumcircle. Okay. So let's say we have drawn a circle which passes through A, B, and C. We don't know right now whether it passes through D or not. I'm not making the statement that it already passes through D. Okay. We just know that A, B, and C are in the circle. So now what I can say is, let's say there is an alternate point D dash here. Correct? D dash is the point that lies on the circle.
okay, sir.
I will prove that D dash is equal to D. That's what I will prove. So let's assume that there is a point here D dash. Now we can say that because it's on the circle, this angle, okay, not this angle. Let me think which angles we should take. So, okay. So what we will do is, this angle is X, let's say. So that will be equal to this much, right? X.
Yes, sir.
Because of same chord AB, right?
Yes, sir.
Similarly, this angle is Y, then that should be equal to this Y.
Yes, sir.
Great. So now I'm getting that angle D dash C is equal to X plus Y.
Yes, sir.
Yes, sir.
But in triangle ABC, what is X plus Y?
180 minus theta.
So I know now that D dash C angle must be 180 minus theta, right?
Yes, sir.
But we already knew that angle ADC was 180 minus theta, right?
Yes, sir.
So that shows us that D dash and D are identical, right? A and C are fixed. Only the third point is the one that is varying, right? The angles are same. D dash and D must coincide. Do you understand what I'm saying?
Yes, sir.
You cannot have another point which is separate and makes the same 180 minus theta, no?
That will just coincide the D point.
So if there was already a D point which makes 180 minus theta, that means D dash is same as D then. And we already said that D dash lies on the circle. So we have shown that D also has to lie on the circle now.
Yes, sir.
Sir, what is your means? What you have firstly assumed
Somebody
that D is,
explain
sir, you have assumed that angle ADC is 180 minus theta.
to prove that. No, I already know that.
Oh, okay, you know that.
Opposite angles of the quadrilateral are supplementary, we already know. We
And you have
don't
proved that
know,
AD.
we know that ADC is 180 minus theta. We don't know that D lies on circle or not.
Okay,
So we don't know that. So what I'm saying is, let's think of a point on the circle. Let's call it D dash.
okay. Then you have proved that D is positive dash.
I have shown that if D dash was on the circle, then I'm clearly getting A D dash C is equal to 180 minus theta. Right?
You were proving
Yes,
for all of
yes,
it.
sir.
So if A D dash C is 180 minus theta and we already know ADC is 180 minus theta, then they should coincide, right?
Yes, sir.
And
Okay,
then
sir.
if D dash lies on the circle, then D should lie on the circle.
Yes, sir.
So that is the basic idea of cyclic quadrilateral. Another way to talk about cyclic quadrilateral is saying this: a quadrilateral is cyclic if and only if angle between a side and a diagonal is equal to the angle between the opposite side and the other diagonal. So we draw the figure and understand that. So let's say we have a figure like this: A, B, C, D. Let's draw the diagonals. So let's say our first side is CD, first diagonal is BD. So angle here is this theta, angle between a side and a diagonal. The opposite side to CD will be AB, right? And the opposite diagonal, the other diagonal is what? AC. So we have this angle here.
Hmm.
If theta is equal to x, or if angle BDC is equal to angle CAB, then it is cyclic.
हाँ सर ये वही angle separated in same segment.
But that is obvious that if it was cyclic, you should realize that the chord is BC, right?
Yes sir.
BC chord is making angle here at D and making angle here at A. So obviously they should be equal. I hope everyone is understanding what is happening.
Yes, sir.
Yes
So
sir.
if the angle between a side and a diagonal is equal to the angle between opposite side and other diagonal, then it is cyclic. And finally, we have Ptolemy's theorem. Is very important and very famous also. It also tells us a condition on cyclic quadrilateral, but a different type of condition, a length condition. A quadrilateral ABCD is cyclic if and only if AC into BD is equal to AB into CD plus AD into BC. Basically, how to interpret it? This is product of diagonals, and this is sum of the product of opposite sides. Sum of the products of pairs of opposite sides. So draw a circle, draw a quadrilateral in it. This is my cyclic quadrilateral, let's say. Ptolemy's theorem, both sides can be proven. The theorem says that AC into BD is equal to AB into CD plus AD into BC. If that condition is true, the quadrilateral is cyclic. Or if a quadrilateral is cyclic, this condition is true. Both sides are true. Do you understand what I'm saying?
Yes, sir.
Yes, sir.
Again, the proof is by similar triangles, but you can use power of a point probably also. You need to try to do the proof yourself.
Okay, sir.
Similar triangles and power of a point are technically the same thing. Power of a point is just one level higher than similar triangles. Do you understand what I'm saying right now?
Yes, sir.
Power of a point itself can be derived from similar triangles, right?
हाँ
Now, basically, it's just a one higher level abstraction. So, what you should do is assume ABCD is cyclic, prove this, and then try to do the reverse. Do you understand what I'm asking?
yes, sir.
Try it as homework. Okay, now I'm not going to discuss too much today. How much have you guys reached in the sheet? Till which problem?
Sir did only till sheet 4 and
Question number? I don't remember which sheet had which
190,
question. Okay.
189.
Okay. You guys should continue trying to go ahead in the sheets. Try a few questions. We'll discuss doubts from the questions in the sheets in the next class.
Yes, sir.
The reason for all of these theorems are, these are the theorems that you need for these problems. You don't need anything extra. All of the problems till 275 are based on what we have discussed theory so far.
Yes,
So
sir.
learn how to apply it. The questions will require some creativity, but it's not like super difficult or anything. You have to try though. So next class, next two classes will be about problems,
Okay, sir.
or maybe three classes. But after that, we will be close to, like, hopefully by then you would have made some progress. Then I want to start the part 2 of the course. So I will start that only when everyone is like okay with part 1. So part 2 of the course is the cool stuff. So far we have been doing lame stuff. But you need to be like, you need to show me that you can handle the next part. Do you understand what I'm saying?
Yes, sir.
Yes.
So all of you need to show me that okay, you guys have tried and many things, many problems you have done, and or you are trying and you are able to do 60-70% of the questions. Then if you are able to do that, then we know that okay, everybody is ready for the next stuff. So
Yes.
I don't have a time limit on it, but the major time limit in my head is like February end. That would be the ultimate time limit. After that, I'm definitely starting this. But if you guys are okay with it before the 275 question number till here, and if you have made some progress earlier, then we can start it earlier. There is a lot of stuff here that I want to discuss, which will be new for all of you. Nobody would have done it, and it will give you a big advantage.
Okay, sir.
Like the theorems and all that we will learn, it will give you like easy ways to quickly solve problems compared to like people who don't know those theorems. And in between, while we do these theorems, we will pause and we'll look at actual INMO, RMO questions and see how they get destroyed by the stuff that we will learn. So I can't wait to teach, but you guys have to be ready. No? It can't be one-way traffic, right?
Mhm.
When you guys are ready, then only we can do it.
Okay,
I
sir.
hope everyone is understanding what I'm saying.
Yes, sir.
Yes, sir.
So just you have to put in a little bit of effort to end this so that we can go to the nice stuff.
Sir, I have a
Okay.
doubt.
Hmm.
Sir, could you please just जैसे कि सर वो होता है like in a triangle P is a point and it is joined from all vertices, then वो area वाला सर questions like नहीं हो रहे सर, मतलब कैसे उसको compare करते हैं जो आपने सीवा में बताया था?
क्या मैं बताया था?
इससे कोई भी ट्रायंगल है सर, आर्बिट्रेरी
हम्म,
ट्रायंगल, कोई आर्बिट्रेरी पॉइंट है इसके अंदर। हम्म। तो सर हाँ, वर्टिसेस से इसको सारे ज्वाइन किया
हम्म,
एंड सर फिर 1 2 3 5 6 ट्रायंगल्स बनते हैं ना सर,
हम्म।
ऐसे नीचे गिरा के, हाँ मतलब टच करवा के। यस सर।
There are 3
ए
triangles.
नहीं, एपी को नीचे बीसी तक टच करवा के। यस सर। तो सर इसके एरियाज कंपेयर कैसे करते हैं सर, वो थोड़ा समझ नहीं आया था,
You have
मतलब
to
साइड का
watch the
रेशियो नहीं
video
है।
again. ये areas compare कैसे करते हैं? You have to look at one vertex, fix the vertex, compare the bases. Like if you right now look at APC, fix the P, compare PB1C and PB1A. Obviously, the bases are proportional.
ओके।
Do you understand what I'm saying?
यस सर।
If you fix the vertex at P and you have two different situations, P is here, A is here, B1 is here, C is here. Obviously, this and this ka ratio will be the ratio of areas.
हम्म।
If you fix the vertex here, the ratio of areas of these two triangles will be in the ratio of this and this.
ओके।
If you fix the vertex here, the ratio of areas of these two will be in the ratio of the bases.
हम्म।
You have to have one common line and one fixed point, which is going to determine the height.
हम्म।
After that, the connections can be in any way, weird way. Now, the ratio of the bases decides the area ratio.
ओके सर।
Do you understand what I'm saying?
यस सर।
Okay, fine. So try the question. I am working hard to create or to prepare for the next part. So there is a lot of stuff that I can teach you guys. Again, I cannot wait actually, but you guys have to be ready for it. No? Otherwise, it will all bounce over your head.
Okay.
Okay. So
यस सर।
yeah. So make sure, do some effort, try to finish as many questions as possible, show some progress, get more confidence in angle chasing. Angle chasing is the basic. Only then we can learn new things. Right?
Yes.
Okay, fine. I'll see you next class.
ओके सर, थैंक यू सर।
Okay, sir.